Okay, welcome back everyone to our last week, the last official week of the class. And it's a different week than normal because we have some stuff coming up to talk about and no new material to talk about. So let's get to the quiz and take a look at how that went. Okay, so here's your quiz. And the first question is to find, the way we read this, is the integral from -1 to 2 of 1 minus x squared dx. So to do that, let's copy and paste it. What we want to do is remember that this symbol means what are we doing? What are we looking for? So when we see that symbol, that integral sign, what are we trying to find?
The antiderivative.
Exactly. We're looking for the antiderivative. So again, it's really a preview of next quarter because this is all you're doing next quarter. So we do one day of it this quarter just to get you excited about next quarter. And we want to find a function whose derivative is 1 minus x squared. And because of properties of derivatives about subtraction, we can do them individually. So you got to think about a function whose derivative is 1. And what is that function?
X.
Yeah, it's x. So the first thing is we can write x, and then we got minus, and then we need a function whose derivative is x squared. We had a little power rule formula. Basically, with derivatives, you go down 1 in the power and multiply by that power. On this one is we go up 1 because we have to undo the derivative and then divide by the up 1 power. So in particular, 2 plus 1 is 3, and it's x cubed over 3. And then it is from -1 to 2. So now, do you remember how to deal with the numbers? When we see that -1 on the bottom and the 2 on the top. So what is the meaning of that? Yeah, we plug in both of them into the entire equation and subtract the top minus the bottom. So let's plug in 2. And when we plug in 2, you get 2 minus 8 over 3. So 2 cubed is 8. Hopefully you know that. And then minus, now we plug in -1. We get -1 minus -1 over 3, which is plus 1 over 3. Any questions on plugging in? Okay, and I would accept that as, finished, but I don't know, it just wants to be done. So let's do this. So we get a 2 minus a -1, that's 3. Then we have a minus 8/3 minus another 1/3, which is minus 9/3. And what's 3 minus 9/3? 0. Okay, this is one of those cases where you get 0 for the integral, and that can happen. Next quarter, when you take Bruce's class, you'll learn all about the geometric meaning of the antiderivative or the integral. This quarter, all we do is play around. Okay, a little preview, and that's it. So any questions on part A? Okay, then there's part B, and this is solve the initial value problem differential equation. So this says dy over dx is equal to 3 minus 4x, and y of 0 equals 7. All right, so the idea here is it's very similar to part A, actually, but there's a couple little differences. Obviously, the function's different. So the first piece of it is saying we know the derivative of a function is 3 minus 4x. So what we want to do is we want to find the antiderivative. So that's the first thing, is we need to find the antiderivative of 3 minus 4x. Any questions on that idea? So I'm going to pop that in the equation. So if dy over dx is 3 minus 4x, then we need to find a function whose derivative is 3 minus 4x. What function's derivative is 3? Start there. Yeah, 3x. And then we need to find a function whose derivative is 4x. And again, if you want, you could use a power rule. It's x to the 1. 1 plus 1 is 2. So we say we're going to have x squared over 2 and then times 4, which is 2x squared. But I'm not done yet. So this is where this problem is different than the first part. And that is, we need the general answer. Yeah, and that's plus c. Okay. And by the way, if you forget the plus c, see if you can remember. I know it's been 10 days, but actually it's been more than that. It's been 12 days. Yeah, you lose 1 point if you forget the plus c. So you won't get it. You won't get 10 out of 10 if you lose the plus c. The plus c is important, but you're actually going to lose more on this one because we need to find c. So we don't just have this, but we have y equals this. And then, so I've used this first part. I've not used yet y of 0, 7. So now it's time to use y of 0, 7. So now you got to remember, what notation is. We have a 0 and we have a 7. Which is x and which is y? Yeah, x is a 0, y is a 7. Very important that you understand how to read a function. So in particular, if y of 0 is 7, then 7 is equal to 3 times 0 minus 2 times 0 squared plus c. And 3 times 0 minus 2 times 0 squared plus c is just c. So that tells us that c is equal to 7. Any questions on that? So now we're ready to answer our question, and that is, what is this function? Okay, well, we know c is 7, so we just plug in. So c is 7. So where I see a c, I put a 7. And that's the answer. Any questions at all? Any questions at all in the quiz?
No.
Okay. This isn't too hard, is it?
This seems pretty easy and straightforward.
Yeah, I do want to give you a gigantic warning. And the good news is I'm not going to be the bad guy in this one. And the warning is everything changes if you even make a small adjustment. For example, if you just, instead of 1 minus x squared, if you looked at, say, e to the x squared, and I asked you to find an antiderivative of e to the x squared, how many of you can do it? So if I said, what is the function? Written functions, and the answer is you can't do it. So just let you know that this antiderivative stuff or this integration stuff, I only give you easy ones. But when it comes down to it, most examples are really brutal. And that's Bruce's job, not my job. But just a warning about next quarter is that it definitely, integration gets much, 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 much harder. Much more than just add the power and divide by that number. You're going to have to do all kinds of interesting stuff. And then half the time you're just going to give up. And that's okay. But you got to know when to give up. But I let you know on the final exam, when you get a problem with an antiderivative, Don't give up because it will be doable. Next quarter is totally different. Any questions at all on this quiz? Any questions at all? Not too bad. Okay, so what I'm going to do next is we're going to spend a lot of time actually talking about the exam that you took. So you all took the exam 3. I know it's probably hardly even in your memory anymore because it's so long ago, but it did happen. And I thought I'd go over that exam, and it's kind of important. And even some weird stuff that happened that I didn't plan on. I don't understand sometimes. Technology is interesting sometimes. All right, so the good news is every single person got question number 1 right. Okay, I think you would have had to be really drunk or something, or just like not having no morals to get problem number 1 wrong. Okay, and that is you need to agree to communicate. So I'll do that. Although maybe I won't. I'll just write key, because guess what? Do you know what adults I'm going to communicate with?
Us.
Yeah, exactly. So I better not put my name on. But again, I'm also not trying to get this for a grade. I did that many, many, many years ago. And by the way, when I took this class, we did not have COVID-19. Okay. But I took it in a much harder way than any of you guys did. I don't know, did I tell you how I took this class?
Didn't you have to teach it to yourself?
Yeah, they put me in a classroom by myself, and they said, if you have questions, don't bother. The internet didn't exist. There was no such thing as email or internet or anything like that. All they gave me is a book. Oh, it's so horrible. So you're lucky. I know I could be mean sometimes, but tell you, having nobody is the worst, and not even other students to talk to. There was no one in my whole school that had any idea about calculus, and teachers, students, anything. So I literally self-taught first quarter calculus, and I got through it, but it was horrible. So as bad as COVID is, I'm telling you, it could be worse. All right, a weird thing happened, and maybe I'll just put in what I didn't want to have happen and then happened. And I still don't understand it at all. But there was this problem that wasn't supposed to be there. I erased it. And it was gone when I did my key. But for some reason, it stuck with you guys. So I want to let you know I made this out of 0 points in the end, because I didn't think it was fair, because it wasn't part of the test. But it could be part of a final. I mean, this kind of stuff. So I want to let you know that just because it wasn't right. But if you look at your grade, I don't know if you can see all the individual scores and stuff, but I think you can. You'll notice that this at the end was out of 0. Okay. If it doesn't show it was out at 0, it was. Again, Canvas does some really weird stuff. So I think what happened is I erased it, but for some reason the erasing of it didn't take. It took on my test when I did a preview, but for some reason it did on yours. But the weirdest thing is that I thought this was the easiest problem in the test. I was really wrong about that. Okay, because even though you had to do it, even though I thought it was going to be gone, it was supposed to be simple, but it wasn't simple for y'all. But I want to do it anyway, because again, we want to be looking forward to the exam. And I could give you, no guarantees, but I could give you a problem like this on the exam. So this is E equals MC squared, by the way. And my guess is you've all heard of E equals MC squared. Okay. Einstein was pretty famous for that. And the question is, show the relative error in energy E due to the change or error in measurement of the speed of light is twice the relative error in the measurement of the speed of light. So again, in terms of doing this one, this is the easiest problem in the test. But I realized it wasn't. And I especially realized it when I saw what you guys did, which is almost all of you had no clue. But it really is not a big deal. Who remembers the formula for relative error. We had a whole section on it. Yeah, it's just dy over y. Okay. So in this case, of course, our letters aren't y because I wanted to be realistic. E equals mc squared is, no one uses different letters than that I've ever seen. But so we want dE over E. So let's write this out. So E equals mc squared. Then, and what we're measuring is the speed of light. Okay. And in fact, I don't know if you know your science, your physics history well. The speed of light was not something they had a good measurement of in Einstein's day. It sounds so obvious now, but if I asked you to go measure it using the tools you have, like a flashlight or something, good luck. But they had some estimates on it. So we're looking at, so C is actually our variable and E is our Y. So in this case, we're looking at dE over, oops, let's try again. Work? Nope, still didn't work. Got to make the over that way. So we're looking at dE over E. And that is equal to, well, what is dE? If E is mc squared and C is our variable, then what is dE? It's not a trick question. It's very simple. Yeah, it's to take the derivative of E with respect to C. So that's going to be 2mc. But then there's a little bit more because it's dE, not dE over dC. So it's 2mc dC. And then E was mc squared. Anyone lost on that right now? Okay. So now it's called algebra, very basic algebra. If you simplify that, what do you get? You get 2 dC, but you get 2 dC over C. And then just to emphasize, because it asked to do it, that's twice dC over C. That's it. That's the whole problem. Because we just did twice the relative error, because the relative error in C is dC over C. Just like the relative error in E was dE over E. And that's the whole problem. Any questions on that? Okay, but I threw it out because I tried to throw it out, and unfortunately it didn't throw out when you took it. It only threw out in my practice test when it had me take it, and I still don't quite know why, but that's what happened. All right, on the other hand, question 2 was not one to be thrown out. So that's Newton's method. And we want to use Newton's method to approximate the solution to e to the x is equal to 3 plus 2x. We want an error of less than 0.01, and we want 2 as our first guess. Okay, and we got to show our work. Okay, any questions on the question? Any questions on the question? Okay, so this is actually a pretty standard problem. You just have to go and do it. And the way to do this is with a table. So I'm going to make a table. And again, maybe I'm going to pop just the first sentence, maybe the first sentence is all we really, first 2 sentences. to give us ourselves a reminder. Okay, so we're gonna make a table. So let's do that. And in our table, we're gonna have our guess, our function at that guess, our derivative at that guess, and then the next guess recursively, and then however many columns, however many rows I need. So we're going to have our, I'm just going to go x because it's easier to type, and then we're going to have f of x, then we're going to have f prime of x, and then the Newton's method formula is what? Who remembers it?
X sub n minus f of x, or the derivative of f of x over f of x.
Yeah. But you either have to all have n sub n's or no sub n's. You choose. I'm going to do no sub n's because it's easier to type, but that's up to you. So
that's why I spoke.
Huh?
That's why I didn't type it.
Yeah, but I'm typing it. So, and I don't want to have to use the equation editor. So it's just x minus f prime of x over f of x. Any questions on that? Okay, our first guess, according to the instructions, was 2. So the first guess is 2. Any questions on that? Okay, now this is something a lot of people have trouble with. We want to solve e to the x equals 3 plus 2x. Do we need, are we trying to find a critical point? Are you asked to find the critical point of this? Yeah, no. This is just standard Newton's method. But what you do need to have to use Newton's method is you need to have it set equal to 0. That's important. If you don't set it equal to 0, it's just not right. So I think I'm going to subtract e to the x. It's a little easier. And we're going to have a 3 plus 2x minus e to the x. And then while I'm there, I should get f prime. And f prime of x is 2. This wasn't supposed to be a hard derivative. Minus e to the x. Everyone okay with the derivative there? Okay, so now that we have that, what we need to do is start plugging in. And some I'm going to do in my head, some I'm not. 3 plus 2 times 2, I can do that in my head. That's 3 plus 4 is 7. 7 minus e to the x. And 7 minus e squared. That one, we need this puppy. Okay. So we need 7 minus e squared. Any questions on that? Okay. And this does have functions, by the way. So I can go 7 minus e squared. And I think I asked for how many decimals? Less than 0.01. So 2 decimal places is just fine. So that's negative 0.34. Any questions on that? Okay. Okay, if you want to do more decimals, you can, but the end, you should, the first and last columns, you should only have 2 decimal places. And then f prime, well, f prime is 2 minus e to the x. And there's a few ways of doing that. I think the easiest way is, remember the f of x was 3 plus 2x minus e to the x. So in particular, when we plugged in 2, that gave us 7 minus e squared, and we want 2 minus e squared. Any questions on that? So that means there should be 5 less. So I go 5 less than that. That one I can do in my head. It saves me time. Negative 5.34. Any questions on that little trick? So then we have to find 2 minus 5.34 over 0.34. They're both negative, so I don't have to worry about it. So then I go ahead and I get 2 minus, and it was 5.34 over 0.34.
So I was under the impression it was f of
Yeah, it's
x
backwards.
over f prime of x.
It is, yeah. Sorry about that. I looked at it, it's like, no, that's not right. I think I listened wrong or something like that. That's much better. Yep. Let's redo that. I apologize. And let's go back to the calculator. And it's 2 minus 0.34, much better. Divided by 5.34. And 1.94. So then we go ahead and we put 1.94 for our next guess. And then we plug in, again, it's a little tedious, but you know, you don't have to go too many. That's the good news. And then we plug in 1.94 into 3 plus 2x minus e to the x. So let's do that. So let me write it down so I don't lose it. So it'll be 3 plus 2 times 1.94 minus e to the 1.94. So let's go ahead. So 2 minus, 3 plus 2 times 1.94 . Oh, good. I was just checking. You don't have to type the numbers. You can just type them in the computer. And then minus e to the 1.94. And you get negative 0.08. So we're getting there. Again, we need it to be 0 to 2 decimal places. Okay, and then we do 2 minus e to the x. So I think I can just go like this. Yeah, that works. And you get negative 4.96. Okay, then we got to do x minus f over f prime. So 1.94 minus f, which is negative 0.08. Again, 3 negatives, so it'll just be a minus when we're done. So 0.08 over 4.96. And let's go ahead and do it. So that's going to be 1.94 minus 0.08 divided by 4.96. And we get 1.92. Any questions so far? It's a little tedious. Definitely the most tedious one there is. Again, in the real world, how do you do something like this? You know, if I asked you to say 20 decimal places, you certainly wouldn't do what I'm doing. What would you do? Don't see y'all jumping in. I'm just telling you, real world. Yeah, you program a computer, the steps for Newton's method, or even better yet, the method that is most efficient on the computer. And then you let the computer do it. But I can't make you do that because I can't assume that you all are computer programmers. But I'm telling you, if you want a good job, it's really good to know how to code. So we have 1.92, and then f of x will be 3 plus 2 times 1.92 minus e to the 1.92. So let's do it. So that's 3 plus 2 times 1.92, and then minus e to the 1.92. Okay. And what we get is 1.94. Okay. And that's because I only carry 2 decimals, but basically we're back. So that means we're basically there. And if you go and carry more decimals, you'll see 1.93 is the answer. Oh, wait, did I get that right? Oh, no, that's not what I want to plug in. 3 plus 2x. I knew something got weird. Much better. Okay, and then we get 0.02. That's better. Was it positive? Yeah. Okay, and then we do the same thing with f prime, which is 2 minus e to the x. So that's 2 minus e to the 1.92, and I get negative 4.82. I forgot to put 1.92. There we go. And then if we plug in 1.92 minus 0.02 over negative 4.82, so it's 1.92, it's minus a minus, that's a plus. 0.02 over 4.82. I lost it. One more time. And I get 1.92. What does that tell me? Yeah, that's it. And there's our answer, 1.92. Any questions on Newton's method applying it? Okay, then we need to find a first guess of x that is guaranteed to make Newton's method fail. What is guaranteed to make Newton's method fail? And the key is you look at Newton's method equation, which is x minus f over f prime. And what will make this fail? Yeah, if f prime of x is equal to 0, we got problems. So what we do is we set 0 equals 2 minus e to the x. And again, if we add e to the x to both sides, take a log, you get x is equal to ln of 2. And that is the one that's guaranteed to make Newton's method fail. Any questions at all on Newton's method problem? Some of you did real well. Some of you thought, I don't know why, but you were trying to find the critical point instead of the where it's 0. And then some of you got log 2, some of you didn't. And there really is only one. Log 2 is the only main choice that you can find that will make it fail for sure. Okay, question 3. Question 3 was a matching. So match the following. Okay, with the proper use or improper attempt, the mean value or Rolle's theorem. So at both 11 a.m. and 5 p.m., the air temperature was 8 degrees Celsius. Then at some time between 11 a.m. and 5 p.m., the temperature was neither going up or down. Okay, so we have some choices, not too many. It's either improper use of mean value theorem, proper use of Rolle's theorem, or proper use of the mean value theorem. Which one is it? Which of the 3? Proper use of something. Okay, you say Rolle's theorem, so let's see. So Rolle's theorem says that the derivative is 0 for some time between the two. And if it's not going up nor down, that's the derivative equals 0. Okay, and notice, by the way, how do we know that this function is continuous and differentiable? Yeah, it's temperature. Temperature can't suddenly go from slow up to sudden up. You know, that just doesn't happen with temperature. Okay, that's just basic, you know, thinking. Okay, until, by the way, if you get really advanced, everything's different, but I'm not going there. But it doesn't happen for us in temperature. So this is the proper use of Rolle's theorem. Okay, if the energy E needed to move a particle from position 0 to position 2 is given by E of x equals 5 plus 3 over x minus 1, then at some point between position 0 and 2, the rate of change in the energy is 3. Okay. So what is this one? We're looking at a Rolle's theorem, mean value theorem. Is it proper or not proper? Or I guess improper is the way I worded it. Yeah, what's the problem with this one if we try to use a mean value theorem? There's an issue. Okay, notice if you plug in 0, by the way, you get 2. If you plug in 2, you get 8. 3 is definitely between 2 and 8, but there's an issue. Or between that 2 over, yeah. So the problem is that the function 5 plus 3 over x minus 1 is not differentiable at x equals 1. And if it's not a differentiable function on the interval, then you can't use the mean value theorem or Rolle's theorem, by the way. So this is an improper use of the mean value theorem because we have a non-differentiable function. Let's look at the third one. If after 3 minutes from the start, a turtle has gone 2 meters, and after 5 minutes from the start, the turtle has gone 3 meters, okay? Then at some time between 3 and 5 minutes, okay, the turtle was traveling at 0.5 meter per minute. What is that one? Yeah, that's a proper use of mean value theorem, because again, if we take f of b minus f of a over b minus a, you get you get 3 minus 2 over 5 minus 3, and guess what? That's a half. Okay. Is this a differential function? What would it mean for it not to be a differential function? It would mean actually not continuous to be teleport. Okay, but it would definitely be some kind of super turtle. Okay, it wouldn't be real. Okay, any questions on that? Okay, changes can't be sudden. And that's just called life. So this is a proper use of the mean value theorem. Any questions on the multiple choice problem? Okay, let's go to the next one. Let's suppose f of x is x cubed minus 3x squared. Find the value where f of x has critical points. What am I looking for? If I want to look for where a function has critical points, what am I looking? Yeah, I want to set the derivative equals 0. By the way, or undefined, but this is a polynomial. Polynomials are differentiable, period. So undefined isn't happening, but we need to find when the derivative is equal to 0. So let's go take the derivative, do the calculus. Let me copy and paste. Always does weird things when you copy and paste. There we go. Okay, so for part A, let's grab this function, take its derivative. Okay, this was not supposed to be tricky at all. What's the derivative of x cubed minus 3x squared? Yeah, it's going to be 3x squared minus 6x. And as we mentioned, we're setting that equal to 0. Okay. So to set that equal to 0, what do we do in one word starting with an F? Yeah, we factor. So we factor out of 3x, and we're left with a x minus 2. I tried to make it easy, but easy doesn't always happen on the test, even though I think it might be easy. So if 3x times x minus 2 equals 0, then x equals 0, or x equals 2. Any questions on that? Again, always easier when you're not stressed out. All right. Some of you did not read the instructions, and this was not meant to be a trick question. So if I say explicitly use the first derivative test to classify the critical point with the lowest values of x, are you allowed to use the second derivative test? Definitely not, okay? I thought, maybe I was wrong, but I thought the instructions were clear. You need to use the first derivative test, not the second derivative test. There were a group of you that used the second derivative test, and that's not okay. Okay, the whole point is I wanted to test you to see if you remembered how to use the first derivative test, and I want to test you to see how you use the second derivative test. So that's why I had a B and a C. So let's use the first derivative test. And I'm going to classify the critical point with the lowest values of x. All right. Which is the point that has the lowest value of the x? What's the value of x? It's not a trick question. So which critical point am I talking about for part B? Yeah, 0. Okay, it's not supposed to be tricky. 0 is smaller than 2. That's lower. I tried to make it simple, but I'm telling you, I'd say a third of you didn't read the instructions. So I don't know what to do about that. So we're going to look at 0. All right, x equals 0. And let's use the first derivative test. The key on the first derivative test is you're supposed to plug in a little to the left and a little to the right. And the main thing is you're not allowed to pass any other critical values. So what a little to the left, what's the easiest value to plug in that's a little to the left? Yeah, -1. So we're going to look at f prime, first derivative of -1. That's why it's called the first derivative test. And again, f prime is 3x squared minus 6x. I plug in -1, and I get 3 plus 6 is 9. What's important about the number 9? Yeah, it's greater than 0. That's all I care about. In fact, I don't even need the number 9. I just need to have greater than 0. And then f prime of, and now I need to get a point that is to the right of 0. What's wrong with using the point x equals 3, for example? Because that's to the right of 0. What would be wrong with saying x equals 3? I'm going to do that one. Yeah, you can't pass a critical point. So let's use x equals 1. I mean, you can use a half if you want, but 1 is the simplest because we haven't passed the other critical point. And f prime of 1 is equal to 3 minus 6 is -3. And that's less than 0. So now that means we're going up and then we're going down, right? First derivative test. So by the first derivative test, what can we say about the critical point at x equals 0? What is it? Yeah, it's a max, a local maximum. If you go up and you go down, that means you're going to the peak. So it is a local maximum. Any questions on that? Okay, now we have to use a second derivative test. Okay, well, to use a second derivative test, the first thing is let's find the second derivative. And the nice thing is it's nice. F double prime of x is equal to, well, what's the derivative of 3x squared minus 6x? Yeah, 6x minus 6. So for the second derivative test, I need f double prime, not of a nearby value, but of that value. In this case, the highest of the values, and that's 2. So if you plug in 2, what do you get? Not supposed to be hard. Yeah, it's 6. And what's the important thing about 6? It's greater than 0. So now you got to remember, by the second derivative test, f has a relative. What is it? What kind of critical point? Yeah, minimum at x equals 2. Any questions on this problem? Okay, it wasn't meant to be any kind of trick problem, but you do have to remember how to apply these derivative tests.
Yeah, I was just curious. I did the exact thing you just showed, and I got 8.5 out of 10 points.
I'd have to look at what you did. I bet there was a small difference.
It might have been how I worded it or something.
Yeah, I'd have to look at it. I could look at it again. That's one of the things you can talk to me in office hours or email me. I could look at it again, but I have to look at it. Honestly, it's been 10 days. I don't have everyone's exams memorized in my head word for word in terms of what they did. So, but that even so, it's personal. So that's the kind of thing that you would talk to me on office hours or email. Okay. Okay, question 5. Find the limit for each and show your work. Okay, so we have an A, B, and a C. So the first one, limit as x goes to infinity. So let's do a copy and paste on this. Okay, so the first one is the limit as x goes to infinity of 7x squared minus 3x plus 4 over 2x cubed minus x plus 6. All right, so what's the trick on this one? What are we supposed to do? Here's the hint. What do we do to find this limit? Yeah, we actually divide or we multiply by 1 over the highest power, but you get the right idea. So we're going to multiply top and bottom by 1 over x cubed. And when we do that, if you have 7x squared over x cubed, that's 7 over x. 3x over x cubed is 3 over x squared. And then we get 4 over x cubed. Then we have 2x cubed over x cubed is just 2. And then x over x cubed is going to be 1 over x squared. And then 6 over x cubed is 6 over x cubed. What's the next step? Yeah, plug in. Remember that we're going to infinity. So if you have a regular number over infinity, that's always 0. So notice that numerator is just 0 minus 0 plus 0. That's just 0. The denominator is 2 minus 0 plus 0. That's 2. So what's 0 divided by 2? 0. Okay, that's all there was to that one. That was probably the easiest of the group. Okay, then there's part B. Part B is a little harder because you have some work to do, some extra little subtle work. All right, so now, same idea. We're looking at highest power. So highest power in the denominator is clearly x squared. I hope that's clear to you. And notice the square root of x to the 4th is also x squared. So highest power is x squared. And the nice thing is that the square root of x to the 4th really is x squared because everything is positive when you have an even power. Any questions on that? So what I'm going to do is in the denominator, I'm going to multiply by 1 over x squared. In the numerator, I'm going to multiply by the square root of 1 over x to the 4th. Any questions so far? And notice I don't need a negative because the numerator is positive, the denominator is positive, so I have multiplied by 1. Even when x goes to negative infinity, the even powers kill that negative. So now we just continue on. And we get 25. The x to the 4th go away, plus 6 over x to the 4th under the root. Okay, and then we get 2 plus 2 over x, or minus 2 over x, and then plus 1 over x squared. And then we plug in. So again, if you have an over x or over x to a power, and you're taking x to negative infinity, you just get 0. So we get the square root of 25 over 2. And hopefully you all know that's 5/2. Any questions on part B? Okay, part C. Okay, now we look at the highest power, and now it's x, because the square root of x squared, that's absolute value of x actually, but it's a single power of x. So we're going to multiply top and bottom. Well, the denominator is going to be 1 over x. What's the problem with the numerator being the square root of 1 over x squared? There's an issue. Why can't I do what I just did? Yeah, it wouldn't be multiplying by 1 because the denominator is negative and the numerator is positive in this case. So we need to make sure the denominator is positive, and I do that by, instead of multiplying by 1 over x in the bottom, I multiply by negative 1 over x. And now when x goes to negative infinity, you really do get 1 that we multiplied by, because in math, you're only allowed to multiply by 1. Okay, then we go ahead and work that out. So I'm going to just pull the negative outside. It's just easier. And we're going to divide by x squared. So the x squared goes away. You get 81. Then we get plus 2 over x. And then plus 4 over x squared. And then we have 3 minus 8 over x. Any questions? All right, now we go ahead and do it. Remember that you get 0 if you have an over x if you're going to negative infinity. So we just get root 81 over 3, which is 9/3, which is 3. Any questions at all on this problem? Okay, let's look at the next one. You're constructing a box for your cat to sleep in. The plush material for the square bottom of the box costs $8 per square foot, and the material for the sides costs $5 per square foot. The box does not have a top. Okay, just a note, by the way, how many sides does the box, how many pieces does the box have? When you're constructing this box, how many pieces does it have? Doesn't have a top. Yeah, it has 5 pieces. Okay, I like to call it pieces. Some people call faces the ones that go vertical. Some just call it pieces. Okay, so it has 5 pieces. Okay, you need a box with volume 6 cubic feet. Okay, find the dimension of the box so you minimize cost. Round your answer to 2 decimal places. Any questions on the question? Okay, so let's copy this. So I've got it down in my work. So what I'm going to do is I'm going to go cost, that's C, is going to be the cost. I'm going to go CV for the vertical pieces plus the cost, how about for the bottom? Because that's what we've got. We got 4 vertical faces, and then we got the bottom. Any questions so far? Okay, we got some work to do. So we know that we have a square bottom. Okay, what is the area of the bottom if it's a square bottom? What's the formula for area if you have a square? Nice and easy. Yeah, x squared. Okay. And then what is the area for the vertical components? What's that going to be? Okay. It's actually 4xh. I'm going to call y. It just feels better math. 4xy. Let y be the height. Any questions on that? That'll be the total area for the vertical components. How about the volume? Capital V, by the way, which is different than lowercase v. What is the volume of the box? Yeah, it's x squared y. And you're told that your volume needs to be 6 cubic feet. So call that 6. Any questions on that? Okay, so in particular, we have y is equal to 6 over x squared. Any questions so far? Okay, so now we're going to go for the cost function. The cost is equal to the cost for the vertical pieces. And that's going to be, again, the vertical is $5 per square foot. So it's going to be 5 times the number of square feet, and that's the area of the vertical for xy. Plus, and then the base is going to be $8 per square feet. So it's going to be 8 times, and then the base is x squared. But that is equal to, now I substitute. So we're going to have, I'm going to do 5 times 4 because I can do that in my head nicely. And that's 20. And then we have x, and y is 6 over x squared. And then we still have plus 8x squared. And 6 times 20 is 120. X over x squared is over x. So I want to stop there. Any questions? Any questions so far on getting the cost function as a function of x? Okay, if I want to minimize cost, what do I do? I don't set cost equals 0. Be nice if I didn't have to pay anything, but that's not going to work. Yeah, differentiate and set it equals 0. Does that make sense? So I need to find c prime equals 0. So I'm going to go c prime equals 0, or, and now let's find the derivative, and this is supposed to be easy, negative 120 over x squared plus 16x. Set it equal to 0. Any questions on that? Okay, and then the rest is basic algebra. So we have, I can multiply top and bottom by x squared, or not top and bottom, left and right by x squared. And you get negative 120 plus 16x cubed is equal to 0. And then add 120, divide by 16, and take a square root. So x is going to be equal, the cube root, sorry, is going to be 120 over 16 to the 1/3 power. And I want 2 decimals, 120 over 16 to the 1/3. So now I just do it. 120. Actually, let's clear that. Parenthesis 120 over 16. Close the paren. And then I want to be to, oops, not there, to the 1 over 3. And you get about 1.96. Okay, and then we want to find out what y is, but y is 6 over x squared. So y is equal to 6 over 1.96 squared. And 1.56. Any questions on this? By the way, here's something that I have no clue on. Was this calculator better for you than the first exam, the other exams?
Yes.
Okay, then I'll put it on the final also.
Yeah, I liked it a lot, especially for the Newton's method problem, because you could actually put in the whole equation and it worked pretty well.
Yeah, I like it
Yeah, I
better,
like
but
it.
again, I don't really know if I like it better because I don't get to see the Proctorians. But I know there's been complaints.
I do have one thing that would improve it is if we
Okay, I
had,
don't know if I can do it. I didn't write it, by the way, so I don't know if I can change
Okay.
it.
it's just about the parameters of the size.
Uh-huh.
It was a little bit, sometimes you'd be scrolling through lines of equations and like it would disappear behind the screen and you wouldn't be able to see like that.
Okay. I might be able to fix that. Yeah, that's a matter of making the vertical a little bigger. Now that I can do. So thanks. Yeah, I'll add 20 or something. Okay, let's do the next one. Find the following limits or state they do not exist. We have a limit as x goes to infinity of x squared plus 4x minus 1 e to the negative x. All right. And then there's a limit as x goes to 0, positive x to the 3x. Okay, so let's go ahead and pop it in. All right, well, if you plug in, by the way, you get infinity times 0. Hopefully you all saw that. And infinity times 0, does that mean does not exist? Right? Or does it mean infinity? What does it? And the answer is we don't know what it means. Okay, it means do more work. So what algebra can I do? It's very simple algebra, but you need to do it. I want to make this look like L'Hopital's rule. So what can I do? It's not hard, but you have to know how to do it. Yeah, we write e to the negative x as 1 over e to the x, and we can write this as a division problem. So let's do that. See if it'll let me. Okay, so we write it as that over e to the x. Okay, so now if I plug in, I get infinity over infinity. And if you get infinity over infinity, you are allowed to use L'Hopital's rule. So then we go ahead and use L'Hopital's rule by taking a derivative of the numerator and the denominator. So if we do that, derivative of x squared plus 4x minus 1 is 2x plus 4. Derivative of e to the x is e to the x. And what do I get if I plug in now? What happens if I plug in infinity? I get infinity over infinity. By the way, when you get infinity over infinity, after using L'Hopital's rule, you always say, is it nicer than I started or is it worse? If it's worse, then don't keep doing L'Hopital's rule. But hopefully you notice that this is nicer. So let's do L'Hopital's rule again. So the derivative of 2x plus 4 is just 2. Now it's much nicer. And now what happens when I plug in infinity? What do I get? I get 0 because I get 2 over infinity and that's 0. And that's it. Always easy if you know how to do it. Okay, let's look at part B. The key on part B is if you plug in, you get 0 to the 0, and that's a bad thing, right? That means we don't know what it is. So I'm going to write y equals the limit as x goes to 0 from the right-hand side of x to the 3x. What's the trick on this one? Yeah, we take the natural log of both sides. And you can bring the natural log through. Because log is continuous and continuous functions are allowed to go through a limit. And then when I have a natural log of 3x to the 3x, I can rewrite that as 3x natural log of x. But I need to rewrite it even more so. Because if I plug in, I get 0 times negative infinity, and that means do some work. So do you remember the trick on this one? And the hint is we want to use L'Hopital's rule. We need a fraction. So it's ln of x over, and then it's ln of x, and I'm going to put the 3 on top too, might as well. The 3 is not the problem. Over 1 over x. And now when I plug in, I get negative infinity over infinity, and that we're allowed to use L'Hopital's rule on. So now we go ahead and use L'Hopital's rule. And the natural log of x, derivative is 1 over x. The derivative of 1 over x is negative 1 over x squared. And the idea on that one is now we can take a look at this and say, what is the limit? How can we algebraically simplify this? So 3 over x over 1 over x squared, and I still have the negative, by the way. I'll throw the negative outside. 3 over x over negative 1 over x squared is just 3x. Oops. And now it's simple. What's the limit as x goes to 0 of 3x? And the limit as x goes to 0 of 3x is 0. So now we have the natural log of y equals 0. So what does that tell us y is equal to? So y must be 1 because the natural log of 1 is 0. And that's part B. Okay, last question, which is good because we're running out of time. Okay, answer the following true or false. Part A, limit as x goes to 0 of cosine x over 3x minus 5 is equal to the limit as x goes to 0 of negative sine of x over 3 equals negative 0 over 3 equals 0. True or false? And how come?
It doesn't equal 0 over 0.
Right. You can't use, so it's false. Since you cannot use L'Hopital's rule for if the limit is not 0 over 0 or infinity over infinity. Any questions on that? Okay, part A was pretty successful. Part B, a lot of you had trouble with. Okay, for part B is if f is twice differentiable, and we know that f prime of 3 is 0 and f double prime of 3 is 0, then it's possible for f to have a relative maximum at x equals 3. Okay, so the idea, this is kind of looking at the second derivative test. What does the second derivative test say if the second derivative equals 0? Yeah, test fails, means anything could happen.
Larry, I had a question about that. And I understand why, because if it's maybe say a constant and it becomes 0, but what if, like the way I read it was that the second derivative of 3 equaled, like the slope of that line was 0. Therefore, isn't that where a inflection point is as well when the second derivative equals 0?
It could be inflection point. It may not be inflection point. So let me give you the example.
Okay.
So I got, for example, written. Y equals negative. We want a relative maximum. Yeah. So y equals negative x to the fourth. Okay. So do you agree that has a maximum? Looks basically like an upside down parabola.
Yeah.
Okay. It has a maximum. Do you agree? Sorry, not x to, wait. Oops. Because of the 3 minus 3. I got to shift by 3. So x minus 3 to the fourth. Do you agree that f prime is 0 and f double prime is 0 at 3?
Yeah.
So this is definitely an example where you can have a relative maximum at x equals 3 when f of 3 and f prime of 3 and f double prime of 3 are both 0. So the second derivative test said anything can happen. It really does mean that. Okay, and that's an example of a maximum. If you want a minimum, just drop the negative sign. You could have an inflection point. If you want an inflection point, make it cubed instead of the fourth power, and you get an inflection point. So anything can happen. Inflection point does not, inflection point, it means that the second derivative is 0, but you have to have more than that. The second derivative has to change signs at that point.
Okay.
So it has to either go from negative to positive or positive to negative to be an inflection point. Do you see that?
Yeah, I see that difference.
Yeah. Whereas if you look at this example, the negative x minus 3 to the fourth, this one actually is does not change signs. The second derivative is always negative, both left and right. It's only 0 at that point. So as an example. Okay, that is the test. I'm going to go a minute or two extra because I want to mention something which I think you care about. And what's happening on Wednesday? Oh yeah, I don't think I answered the question because I was in a rush, but so true.
Oh, wait, Larry, I thought it was false. Wouldn't it be false then? If both of it failed?
It is possible. The question is it possible?
Oh, okay.
The answer is yes, we found an example, so it's possible. Do you see that? So that's a logic. Okay, let's go back. So Wednesday, you have your presentations. Okay, and very important to be ready for that. So I figure I should mention there, I think. Yep. So you need to have a presentation that is an application of calculus. Okay, so not pure math. It needs to be some use of calculus. Okay, and you're gonna log on Zoom. We are not going to be recording because some people feel nervous about it, which means you should have your camera on. It's just you guys, no different than being a face-to-face class. You get to see each other, but I'm not going to record for the world. So you're welcome to record and on your own computer and publish on YouTube or something if you want. But I'm not going to because of privacy issues. But there's no privacy issue for if it's not recorded and you get to see each other. That's just being in class. So that's just a note. Here's the step-by-step thing you're going to do in the presentation. What's the very first thing you're going to do? It's obvious.
Introduce ourselves.
Exactly. Introduce yourselves. Okay, say who you are. Okay, that's important. So first thing, don't forget to introduce yourself. By the way, if I'm looking down a lot, that means that I'm taking notes. Okay, because I got to grade you. So don't think I'm being rude or mean or hating you or something if I'm looking down at this instead of looking up at the screen. Okay, just a note. So you're going to introduce yourself. Make sure you have your microphone on, your video on. You're going to share your desktop so that they can see. If you want to do PowerPoint, you can do PowerPoint or whatever you want. It's on your desktop, so you're presenting. It has to be an application, so that's necessary. So you need to have some kind of application, hopefully something interesting. Otherwise, you're going to bore the hell out of everyone, and you don't want to do that. So you should do something interesting that everyone's going to, be interested in. In your presentation, I need to see a derivative, okay, or a limit, okay. If you don't have a derivative or you don't have a limit in your presentation, then that's bad because then you're not using calculus. Does that sound fair? You should make the presentations around 5 minutes. Definitely don't go over 10 because we'll run out of time. So, 5 minutes, six minutes, fine. But don't try to make it an hour presentation. We do not have time for that. Okay, because all of you are going on Wednesday. It is important that everyone is there. You need to all be in attendance Wednesday. Wednesday is like the big attendance day. If you can't make it at 8:30, but you can make it at 9, that can work. Just make sure you jump in when it's time and you're all there. But hopefully you can all be there. Okay, and don't log off. Don't be rude to each other. Try and stay on the whole time. So that's kind of the idea. Is you're presenting, you're talking, and also very important is that each person of your group, whether it's 2 or 3, you're allowed to have 2 or 3, needs to be part of the presentation. So it's not one of you presenting, it's all of you presenting. So take turns. Okay. And I recommend practicing, it's only, it's 5 to 10, a little more than 5 minute presentation. So it doesn't take long to practice. So make sure you practice it live by yourselves at least once before you go live with everyone else. You should show the calculus. Okay, don't just say we did some calculus, actually do the calculus. Okay, because remember, this is a calculus class. And don't assume everyone has been thinking about your problem for the last week or 2 like you guys have. Make sure you really explain what the problem is, because they're all coming from never seen it before, possibly. So I think I'm going to close off, but I'm in office hours, but I'm going to kill the sharing. And again, I won't be sharing anything. There won't be a YouTube video on Wednesday at all. Okay, there will be today if everything works well. So I'm going to stop share and stop the recording.